Welcome.
So as people, I think that a lot of us share a real urge to know our place in the scope of humanity, to know where we fit in the rest of the world. And I would argue that humanity, as a species, actually has a yearning to know our place in the universe. And I think that the best evidence for this is, of course, the fact that we spend our time looking for planets around other stars. Now, of course, we don't just want to find any planets around other stars. I mean, I'm an astronomer, so I think it's great when we find any planet. But a lot of what motivates this is our yearning to find a planet that's like Earth. And that yearning is now in the process of coming true, and in some sense is very much part of our future and lies just out of our reach. Incredibly, for the past, well, all of human history, we've really only known about one planetary system, and that's the one that we reside in. So our Earth, our 7 sister planets, and the countless small bodies that orbit our sun and make up our planetary system were really the only example that we had in the entire universe of a solar system. And for perspective, this is a little like if everything you knew about the Earth was limited to your house and the other houses that you could see on your block. Now, of course, as long back ago as the ancient Greeks, people postulated that there were planets orbiting other stars. But we really didn't know whether that was the case. And what's more than that, we really had no way of finding out either. And so just that possibility was enough to get us to start dreaming. And of course, dreaming often leads to scheming. And that has led to a lot of the development of the technologies that now make it possible for us to find planets around other stars. And so it's really just been in the past couple of years, really the past few decades, but especially recently, that we've started to understand the Earth's place among its neighbors. Now, over the past couple of years, as we've developed the ability to detect planets around other stars, one of the messages that we keep getting is that planets are really ubiquitous. We've now broadened the scope of what we know about solar systems out from our own solar system to the solar neighborhood, the collection of stars that are nearby to the Earth, astronomically speaking anyway. And what we find is that most places we look, and the better our technology gets, we find planets everywhere. And so now we have a picture of our planetary system not as just a lone face in the mirror, but in fact as a face in the crowd. As we've broadened out what we know, what we're faced with is that we now know our neighborhood, but actually we've really just started to look. So our searching area in our own galaxy has actually just been a very small part of the fraction of the galaxy as a whole. Now, this might seem daunting. I mean, the galaxy is a very big place. But one of the things that's so amazing about this is that the worlds that we know of, those that we have discovered, imply the existence of many other planets just like them. And that means that we're not just a lone, solitary planetary system, or that it's just us and our nearest neighbors in our neighborhood. It means that our galaxy is likely to be filled with billions of other planetary systems, likely many of which contain planets like Earth. So just in the past 4 years or so, there's been a huge explosion in the number of planets being discovered. And that's been in no small part due to NASA's Kepler mission, which I'm showing here. So Kepler is a space mission. It's a telescope that orbits just behind Earth, and it's dedicated to finding planets around other stars. And in the past 4 years, since we launched in 2009, Kepler has actually found over 3,000 potential candidate new planets. To give you some sense of perspective of what a huge uptick that is in the rate of which we find planets, in the previous 2 decades of searching, there were about 400 planets known, because it was such difficult, time-consuming, hard-scrabble work. But with the launch of Kepler, in just 4 years, to have now possibly more than 3,000 planets, it's amazing. Now, the way that Kepler works and what makes it so incredible is that it looks for the little tiny dimming of stars. So what it does is it measures the light from stars very, very precisely and very constantly with time, every 30 minutes or so. And it's looking for planets to pass between us and the star and to block just a tiny little bit of the light from that star from getting to us. Now, if we see these little dimmings in the light and we see them recur again and again, then we know that there's a planet that must be passing in front of the star and blocking that light. And we can actually measure also how long it takes to recur, and that tells us the length of the planet's year or how long it takes to get around its star. And so this has been really amazing because Kepler is actually capable of measuring very, very tiny changes in the light, and that means that we can find planets that are very small. You see, planets have traditionally been very difficult to find because they don't really give off light of their own to speak of. Not much, anyway. And that means that they're often outshone by their own star, and at astronomical distances, truly astronomical distances, they're really hard to spot. And so we're always in the position of indirectly detecting them in almost all cases. But with Kepler, we can look for these little tiny dips, and we can infer that the planet is there. So, in the past 4 years of looking, we've not only found that there are ubiquitous planets everywhere we look, but Kepler is the first mission that's really been capable of detecting planets that are as small as Earth. So I keep saying that it's important to find small planets, and you might wonder why that is. Well, in our own solar system, the smaller planets, ones like Earth, Mars, and Venus, are the places that either currently hold life or were thought to have held life once in the past. And because a lot of our goal searching for Earth-like planets is to actually find something that might be potentially habitable, we focus on Earth and some planets similar to Earth because that's the one example that we have of a planet that has life on it at the moment. And so it's our hope that by looking for planets that are like Earth, we'll be able to recognize a habitable planet and even perhaps an inhabited planet when we see it from afar. And what's so encouraging about these results from Kepler is that the smallest planets, those that we think might be the real estate where we can look for life, are actually the most common of all of the planets that we've found. So this is really exciting. And it might interest you to know that these discoveries were really a long time in coming. So what made Kepler's discoveries possible? Well, Kepler actually launched almost to the day 25 years after it was originally proposed. The man I'm showing you here on the right is Bill Barucki, the head of the Kepler mission, shown celebrating just a couple hours after we launched the telescope. But what I'm showing you on the left is a paper that he published back in the mid-1980s with a couple of collaborators, suggesting that such a mission would be possible. Now, at the time, we had really just started to use what are now the ubiquitous replacements for film in your digital cameras, CCDs. They were relatively new, and they weren't really capable of making the kind of precision measurements that Kepler now makes. And so, conceptually, sure, a mission like Kepler would work, but it was technologically infeasible at the time. But Bill is very stubborn. And so, over the past 25 years prior to Kepler's launch, this idea stayed alive. And what's so incredible is that in that time, these detectors got better. And probably our best example of the improvements of technology in space are what are probably familiar to many of you, the Hubble Space Telescope images. So the Hubble Space Telescope was launched just in the early 90s and has since had many instruments swapped out and improvements into its technology over time. And it's responsible for giving us these images that not only allow astronomers like myself to understand the universe, but also have really seeped into the public imagination. And it's tempting when you look at Hubble images to think of them as just being photographs taken on their aesthetic merits. But these are scientific data, and in their beauty they encode meaning to the physical reality of the world around us. And it's not many scientific experiments that can say that they've so seeped into pop culture and the public consciousness that we see them really everywhere we go. And it's not everybody's data that you can say that of. So these images are incredible, And our technology has improved so much, and now we're finding all of these things. But what might interest you to know is that it wasn't actually just the increase in our ability to use this technology that made Kepler possible. In fact, it's been a long time since our technology really changed substantially. But what has changed is the way in which we use it. So we tend to think of our sky as being sort of a static painted ceiling. And as beautiful as those Hubble images are, they're just, for the most part, single images, a single snapshot in time. What made Kepler possible, though, was the ability to not only take a single measurement, but to measure how those stars are changing in brightness with time. And that means acquiring, processing, and being able to store a vastly larger data set than we ever have before. And so now it's not just about our technology that we have, but in fact the way that we're using it and our ability to analyze that data that's made something like Kepler possible. It may surprise you to know that Kepler actually doesn't take beautiful images because its power lies in its ability to measure change, not in its ability to capture a single beautiful instance in time. So when you look up at the night sky and you look at those images, I want you to remember that the night sky is not a static ceiling, that in fact our universe is a dynamic place that changes not just slowly on the order of billions of years, but also on human timescales, on seconds, minutes, hours, days, and weeks. And our ability to measure these changes and to understand our universe as a dynamic place is really just beginning now, and we're entering what we call the era of time domain astronomy, where we measure not just single snapshots, but entire evolutions of events. And this is really, I think, enhancing our understanding of the universe and also challenging some of the things that we know. So just as film really changed the way that we understand our physical world around us here on Earth, I think that the ability to make multiple measurements and to use our telescopes in this way that we see changes over time will really revolutionize what we're able to learn. After all, the measurement of just the shadow of that planet galloping across the face of its star is not something that's possible with just a single measurement, and it's really difficult if you only have a few. What it relies on is multiple measurements, very precise measurements, and lots of them over time. So, what's next? Well, the image that I'm showing you here is of the Large Synoptic Survey Telescope, or LSST for short. This is a future telescope project that will be on at the end of the decade. And what LSST will do is monitor, sweep over the entire night sky every few nights for 10 years, creating essentially a gigantic cosmic movie, 10 years in length. When its construction is completed, it will boast the world's largest digital camera at over 3 billion pixels. It will be able to see the asteroids and comets that could potentially threaten life here on Earth. It'll be able to find planets, and it will be able to study the stars that they orbit, and even see the end states of stars, the huge cosmic explosions far, far into the realms of cosmic space. But as we go forward with this quest to better understand our place in the cosmos, it's important to remember that even though this will be an amazing state-of-the-art project, it's not just about the technology we have, but the way that we use it. And so as we find our place in the cosmos, we must remember that we are in fact the hands that wield technology. And our technology is only as good as our tenacity and our vision and the way in which we guide its use. So as we discover the amazing world around us, it really is an exciting time. And I think that we'll both find the planets that we seek that are twins of our own and things that we haven't even dreamt of yet. Thank you.